Hello, I am Alfredo Hernandez-Garcia, the sauce, and this is my second lab journal that I did not procrastinate in. Okay, so this is the pump problem. So what I like to do to start with this off, just give my equation for force. Force, Newton's law, it's mass times acceleration, and mass is equal to density times volume, and volume is equal to cross-sectional area times height or distance. And so we could say force is equal to density times cross-sectional area times distance times gravity, because gravity causes objects to accelerate. And so here are some numbers. The standard density of water is 1,000, and the acceleration due to gravity is 9.8. And then here I just have that work is equal to the integral from A to B of force. And so we're given a cylinder tank in which we're pumping water from on the surface of the tank. It has a radius of 8 and a height of 3. And so to find the force in our problem is just plugging in all these numbers into my equation for force. And so I have this 64 pi because it's the cross-sectional area. The cross-sectional area of my cylinder would just be the area of this circle, which is pi r squared, and r is 8, so it'll be 64 pi. And then my distance changes as the water level goes down. It'll be 3 minus y, because it's vertical. And then my gravity. At the end, I ended up with 627,200 pi. And so work will be equal to this integral right here, which I will use for all of my questions. And so in order to find how much work is needed to empty the pool, I'll find my integral from 0 to 3. And at the end, after doing all this math, I ended up getting this very big numbers in joules. You can also say it's 8.86 times 10 to the power 6 joules. Now for B, I had to find how much work is needed to empty just the first meter of water from our tank. And so I just, instead of going from 1 to 3, I went from 0 to 3, I went from 0 to 1. And they were giving me this number in joules, which I could also say is 4.9 times 10 to the power 6. And then at the end, our pump moved. Instead of being on the surface of the tank, it's 5 meters above it. And so since the pump moved, our distance changed. And so 3 meters of the tank plus 5 is 8. And so our distance changed from 8 minus y. And so we're going to empty the pool again. And so going from 0 to 3. And instead of 3 minus y, I have 8 minus y. Doing this math, I have this very big number in joules. You can also say is 3.84 times 10 to the power of 7. And that is it. The sauce is out.